Glass fiber reinforced concrete, GFRC, has been used for the past 50 years to produce many concrete products, especially thin architectural cladding panels, also for ornamental concrete such as domes, statues, planters, and fountains. Recently, decorative concrete artisans have discovered the benefits of GFRC for decorative panels, such as fireplace structures, concrete countertops, and artificial rock work. GFRC market is expected to almost double by year 2030. The aim of this introductory lecture is to shed light on this rarely used product in our region, which has very high profitability and quite easy to undertake. GFRC stands for glass fiber reinforced concrete that can be used for a whole host of applications due to its resilience and lightweight. It is similar to chopped fiberglass, which is used to form boat hulls and other more complex shapes, although GFRC is not as strong. It can be used to construct lightweight panels as it can be made thinner and lighter than traditional concrete. It has good weather resistance besides being fire retardant. These products are almost maintenance-free. Gray Portland cement should be avoided if you want to add color, as the dark gray pigment is hard to overcome. Overall, white cement is the better option, but it is more expensive than gray. It is worth noting that silica sand is most suitable for GFRC. However, sieved ordinary sand can also be utilized. AR glass fiber is available in chopped strands, in a ball of twine known as roving, and as scrim, which is a grid-like pattern that is sold on a roll. Water to be used should be free from contaminants and as clean as possible. Dispersants are able to produce stable and durable mixes even when combined with the high pH levels of Portland cement. Superplasticizers that reduce the amount of water needed by up to 30% are also available in market. Pigments are available in a wide range of colors. The more pigment you use, the more intense the color. The process of making GFR concrete is simple but must be followed in the correct order to avoid a lumpy end product. For optimum results, opt for a high shear mixer. Liquids should be mixed at the rate of 300 to 500 revolutions per minute. After adding sand, the mixer is set at high speed ranging between 1000 to 1800 rpm. Once fiber has been added, do not mix for too long or at too high a speed, as this can damage the fiber, resulting in reduced strength. And remove any entrapped air using either a hand vibrator or vibrating table. For higher volume, slurry can be sprayed into molds using rotor, stator or peristaltic pumps that are specifically designed for GFRC. Once face coat has stiffened, a fiber backup mix is applied in multiple passes, with compaction between each pass. Curing temperatures should be maintained above 50 Fahrenheit or 10 degrees centigrade. GFR concrete is widely used in construction works. Some examples are displayed on the screen. It is most commonly used in exterior cladding. However, due to its strength, flexibility, and chemical properties, GFRC can be used for a wide range of applications. It can also be used for modular buildings, as well as walls, roofs, floors, and foundations, as it can take the form of pretty much any shape or size. It is used in architectural features such as moldings and landscapes. GFRC creates items such as fountains, statues, domes, and planters. It can be used to create almost anything that traditional concrete can, and it has the added benefit of more aesthetic options for users. Whether you opt for the spray-up option, which uses a liquid concrete mix that sprays glass fibers, or you go for a premix in which the liquid concrete is poured into molds, glass fiber reinforced concrete is suitable for a variety of different projects and guarantees a superior finish. Important web links related to Technology Education and Mentoring Center are flashed on the screen. More lectures have been designed by our CMB team introducing new materials that can improve profitability besides having environmentally favorable manufacturing processes.